Amazon Simple Notification Service, or SNS, is a publish-subscribe service managed by AWS. Now, it enables asynchronous communication between publishers and subscribers by using messages. In an earlier video, I showed you how to use AWS Lambda Functions to process messages coming into an SNS. I highly recommend checking that one out if you're completely new to SNS and Lambda Triggers. In this video, we will learn some of the disadvantages of processing messages directly from an SNS and learn how introducing an SQS queue in the middle solves some of them. I will show you how to set up the integration from SNS to SQS and still process the message using a Lambda function. Hello everyone. My name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Azure, AWS and Cloud. This video is sponsored by AWS and is part of my .NET on AWS series. Without much delay, let's learn how to set up an SNS with an SQS to process the messages. Here, I have my AWS console open, so let's navigate to the simple notification service where I already have a topic set up. Now this is the same topic that I used in my previous video where I explained about SNS and Lambda Triggers. Now let's navigate into user changes and we can see the current subscriptions on this topic. I have a subscription to a Lambda function. So if I click this, I can see the details of this subscription. Now you can see this is triggered to an SNS trigger Lambda function. So let's open the console in a new tab and navigate to Lambda Functions. Under this, here I have two Lambda functions. One of them, which is the SNS trigger, which is the Lambda function that is used for this subscription. Now anytime I put a message into this topic, this subscriber receives the message and processes that. So let's navigate back to the user changes to the topic and let's send a message. So let's click publish message and let's click test and send the body as test as well and click publish message. Now this is sent to the topic, which is then sent to the subscriber again, and the Lambda function processes this message. Now if we open up the Lambda function code, so this is the SNS trigger function code, all it does is receive the SNS event. It loops through the records, which will always be 1 like we saw in the previous video, and it processes this record. Now if it contains the word exception, it will throw an exception. If not, it will simply log saying process record and simply write the message into the log. We can see these logs in CloudWatch. So if we navigate back to the console, if we go to the Lambda function, let's go to monitor and open view logs in CloudWatch. Now you can see the log for the message that we just sent. That is one log stream. So let's open that. And this writes the exact message, received message with records 1, and it says processed record test. Now, as long as these messages are getting processed successfully, we are all good with the subscription and using the Lambda function. But the moment one of these messages throws an exception, we hit the asynchronous retry loop. So with the SNS, we saw how it is asynchronously invoking the Lambda function, which means it does not wait for the Lambda's response. All it does is simply drop the message from the SNS into the Lambda's event queue. Now it is Lambda's responsibility to process or retry these messages in case of errors. So as far as SNS is concerned, it has successfully delivered the message. Now in these cases, there is the Lambda's asynchronous configuration that kicks in and enables the retries. This is something we explored in the previous video as well. So to quickly recap, if I come back to the SNS trigger, under the configuration, if you look at asynchronous invocation, we can see here the retry attempts is 2. Now we can set up a dead letter queue service here to send these messages when they error. So in this specific case, currently the Lambda function, if it has an error, it will retry 2 attempts, first one after 1 minute of the first message, and then it will send again after 2 minutes. So in a total of 3 minutes, we will get 3 messages with the same exact body when it is erroring out. Now this works fine if it is a transient error and if it gets processed when it is retrying. But if it's not a transient error and something that you need to handle at a later point, then these messages currently disappear. However, you can set up a dead letter queue service and handle these messages in the dead letter queue. Now we also saw this in the previous video. Now, once you set up a dead letter queue service, you will need another processing or Lambda function to process the message from these dead letter queues, which could be an SQS. Now, to set up a dead letter queue, we can click Edit and select the dead letter queue. You can choose again between an SQS and an SNS. So based on your preferences, if you're selecting SQS, you will have to say the queue name as well. So once you set these up, any messages that error out after the number of retries, it will be sent to the dead letter queue. However, to process them, you again need to set up a Lambda function or some other process for your team and based on your application needs. We also saw when there is a sudden spike of messages coming into the SNS, the Lambda functions are scaled based on the scale configuration. Now, since only the messages is processed one at a time, we cannot batch these messages. So if I open up LinkPad, which is a tool to run .NET scripts, you can simulate a load of messages coming into SNS. So let's say, for example, I'm going to send 50 messages in a loop and then click Run. Now this is going to run 50 messages into our SNS, which is going to scale up our Lambda functions. Now if we look at the concurrency setting, we can see currently it is set to 1000, which means it can scale up to 1000 Lambdas concurrently. So if I come back to our CloudWatch and refresh this, you can see there are around 50 log streams that is getting created. This is because I just sent 50 messages. Now each of them is going to be picked up by one Lambda function and it only picks up one record at a time. This also ends up increasing the cost of using the Lambda functions because it can only process one message at a time. So now let's see how we can introduce an SQS queue in the middle to process these messages. So how this would look like is we would have SNS, which is going to be sending asynchronously messages to an SQS, and we would still be processing messages from SQS using Lambda functions. Now, if you're completely new to SQS and Lambda functions, I highly recommend checking out my video where I walk through the entire process and the different configurations associated with it. Now, to quickly recap that, we have an SQS queue inside my same account. So if I navigate to the AWS console, let's open Amazon SQS, which is simple queue service. And I have an existing queue inside that, which is the user data changes. So if I navigate further into it, you can see the configurations inside this. Now there is a Lambda trigger section where I have set up a Lambda trigger. Now this is wired up to the user data SQS trigger. So if I switch back to the Lambda function, if I navigate back to functions and open the SQS trigger, you can see this Lambda function is what is processing messages from the SQS. Now if I come back to SQS and send a new message, so let's say test and send this, this is going to drop the message into the SQS, which is going to be processed by the Lambda function. Now the Lambda function, very similar to the SNS function, is getting an SQS event in this case. Now in this particular case, we had set up batch response, which means if you're processing a batch of messages and a few of them fail, you can explicitly tell which of the items failed, which means the SQS would just retry those messages and can remove the messages that were successfully processed. In this case, the SQS could get more than one records. This is based on the configurations that we set up on the trigger. We explored all of these in the SQS Lambda video. So I highly recommend checking that out if you're new to a lot of these concepts. Now all this does is loops through the message records and processes this message. Again, very similar to the last one, if the message or the body contains an exception, it will throw an exception. Otherwise, it will simply process and say a log information. So now if I navigate back to the AWS console, if you go to the SQS trigger and go to monitor and go to view logs in CloudWatch. Now you can see one log stream record coming into this for the message that we just sent. So if we navigate into that, we can see there is a received message count of 1 and it says processed message test. Now let's see how we can wire up the SQS to send messages to SNS and then process it from the Lambda function. So let's come back. Let's delete this message log stream so that we can clearly see what is happening. Now to set up the integration, let's come back to simple notification service. Let's go into the create subscription to create a new subscription. So under protocol, instead of choosing AWS Lambda, we will choose AWS SQS. Now let's give the endpoint. In this case, we will choose the user data changes SQS. Now you have an option to enable the raw message delivery. So if you enable this, it means the raw message would be sent without any of the headers from the SNS event itself. This is exactly what we need in this case because we'll just get the message that is from the SNS. Now, if you require the additional metadata from the SNS, you can uncheck this and update your Lambda function to process accordingly. So let's click this for now and let's create the subscription. Now, once the subscription is created, let's come back to user changes to the topic and publish a new message. So let's say test and let's say the raw message test and send publish message. Now this is going to publish the message. So if I was to go into the trigger for the Lambda function, that would have received it as well. However, we are interested in the SQS integration. So let's come to the SQS trigger CloudWatch and let's refresh this. Right now, we don't have any messages coming into this. This is because we haven't added the permissions for the SNS to send message into SQS. Even though this is not showing any errors inside these subscriptions, we will need to set up the permission for this SNS to send messages to the SQS. Now, to do this, all we need to do is add an access policy into the SQS. So I will be copying this, which is exactly the statement that we need, and I'll walk you through this in a moment later. So let's come to our SQS and update the policies so that the SNS can send messages to this SQS. So let's click user data changes. Let's go into access policy and let's click edit. Now this is where you can set up the policy for this particular SQS. Now I have one already written, so let me copy and paste this inside here. Now let me paste this. So if you can see, all I have added is in effect allow for the principal service SNS, and then it's specifying that it has the action SQS send message, which means it can send a message to this SQS. Now the resource that we are acting upon is this user data changes, which is the current SQS to which we are adding this policy. Now we are also adding the condition so that not all the SNS is able to send, but only the one with the source ARN, that is of user changes. Now this is the topic that we are interested in. Now these are my account numbers, so this is simply the ARN of these resources. Now once you have this statement written in, you can click Save Changes, which will add this permissions for this SNS to send the message into SQS. Now if I come back again to symbol notification service and go to user changes and publish a new message, we should be seeing that inside our queue. However, note that the message that we sent before is completely lost. So let's send a new message. So let's say test new and send the message as test new as well and click publish message. Now if I come again to the Lambda trigger CloudWatch and refresh this, I should be seeing a log stream appear in a moment. Now you can see a new log stream. So let's click that and you can see there is received message count of 1 and processed the message test new. So we have successfully set up the integration from the SNS to send messages into the SQS, and we have a Lambda function processing these messages. Now, in case of an error message, so we saw that if there is the word exception in the message body, we will be throwing an exception. So let's come back to simple notification service. Let's publish a new message. Let's say test exception, and let's send the message the same and click publish message. Now if I come back into the Lambda CloudWatch and refresh this, this message should get picked up soon enough. Now you can see this message has received. It's received the test exception and it says message cannot be processed. Now these messages gets retried based on the configuration of the queue. So if I go back to the Amazon SQS, let's expand this more and you can see here the settings that's available. Now inside the dead letter queue, you can see we have set up a dead letter queue to send the error messages, and it says we have a maximum of 2 receives, which means the message would be retried only once. So now if I come back to the CloudWatch and refresh this, this message is retried again. So you can see the processed message test exception appearing twice. Now once this has processed 2 times, it is going to move this message into the dead letter queue as specified inside this configuration. So now if I open the queues in a different tab, let's go into the user data dead letter queue, which is the queue that is set up here for the dead letter queue. So let's navigate to that and say send and receive messages. So now let's say poll for messages, and we can see the message that we have just sent, which is the test exception. So the message from SNS was delivered to our main SQS queue, and since it had an exception, it retried for 2 times based on the queue configuration, and it sent to the dead letter queue. Now once you figure out these issues with these messages, and if you are able to solve them, you can redrive these messages into the main queue. So if you look at the start DLQ redrive, you can redrive this to a different custom destination or to the actual source queue and select DLQ redrive. Now this will send the messages again to the main queue and get it processed again. Now in this specific case, it is going to throw an exception because my message is always going to have the word exception. But in a real world condition, if you have fixed the bug or if it's an external third party that was causing an issue, once you have resolved it, you can redrive these messages and have it reprocessed. So if we go back to CloudWatch and refresh this, you can see that the message has come back again here. Now we have the processed message test exception 3 times. So you can see it 1, 2, which was the first time delivery and the retry. And this is when we have redrived the message from the dead letter queue. Now this message is going to again come and then land back in the dead letter queue after 2 retries. So you can see this message has come back once more. So if I go back to the SQS in the dead letter queue and say send and receive messages and poll for messages, that message is again inside the dead letter queue. Now this makes it seamless to process the message and also retry the messages in case of errors. Now since everything is inside the SQS, you just need one Lambda function to process all of these scenarios. Now let's see when there is a spike of messages, what happens. So let's go to the CloudWatch. Let's clear these logs so that we can clearly see what is happening. So let's delete all of them and let's send the spike of messages 50 into the SNS queue. Now this is successfully sent 50 messages. So let's come back to our SQS trigger and refresh this. Now in this case, we only have 2 log streams created as of now. So if we navigate into one of them, you can see that the same Lambda function was used to process these messages. Now in these cases, you can see all the messages count that was received was 1. So if you navigate to the other log stream, you should be seeing similar behavior. Now this is because of the configuration that we had set up on the Lambda trigger. But we still had only 2 Lambda functions to process all these messages. It did not create 50 Lambda instances to process each of those messages. So you are able to control the throttling of the Lambda functions much better in these cases. So if I come back to the Lambda function trigger, so let's go into the configuration and let's edit this SQS trigger. So let's click edit and let's update the batch size. Now currently this is set to 1, which means only a maximum of 1 message is sent in each batch. So let's send 10, which means a maximum of 10 will be sent. We can also set up the batch window, which is the time in seconds that it will wait to collect these 10 records. So if we specify this as 10 seconds, it will wait for 10 seconds to see if it's able to get 10 messages. If not, it will deliver whatever it has received. So let's update these two and click save again. Now if I come back to CloudWatch, let's delete these logs to see clearly what is happening and let's create another spike. So let's send these messages again and let's come back and refresh the logs. Now you can see in this particular case, we have 3 Lambda functions created. So if we navigate into one of them, you can see in this particular case, there was a message count of 10, which means one Lambda function is processing 10 records at the same time. So now we are able to batch the notifications that's come into the SNS and process them as a batch using the SQS queue. So now if we navigate back to the other log stream, you can see this is processed more counts. So first one processed just 1, but then one of them had 10 records inside this. Now setting up the batch record to 10 does not guarantee that you will always get 10 records, but this is up to the Lambda function. But when you have large amounts of messages, you will almost get the batch size as the number of records. Now again, if one of these messages is erroring out, so let's come back to the script and modify it slightly so that it sends an error message. So let's say if the E is divisible by 5, we will add an exception message. So let's update this code to send exception if the E is divisible by 5. So let's add parentheses before these. So let's specify E %5 is equal to 0, which means it's divisible by 5. In this case, we will add the word exception. If not, we will simply leave this as empty. So let's copy and paste exactly the same for the below one as well. Let's also make sure we include the E in the message. So let's open another braces and put in the E to the end. So let's do that for the same for the below one. Let's also make sure to use capital E here because it is a case sensitive comparison inside our SQS trigger code. So if you see here, it checks for contains exception. So let's make sure that matches and send the bulk of messages. Now this is going to send 50 messages, of which all the ones that has divisible by 5 with the integer is going to be having the word exception. So if I come back into the CloudWatch, let's refresh this. Now suddenly the spike of messages has arrived. Now since there is a spike of messages, we will be seeing multiple processing records. So you can see here this is received 10 messages and it is processing all of them. Now for the counts that is divisible by 5, you can also see the message cannot be processed log. This means this is thrown as an exception and it will be retried. Now you can see this has already picked up different batches of 10 records. If we navigate back to the trigger, you can see there are 2 streams, which means 2 Lambda functions were triggered. Now both of these are processing the records. Now as soon as the error messages are sent back, now since we have enabled batch failure, which means only the errored messages will be retried. So after the queue's default timeout, which is 30 seconds, it will put these messages back into the queue and it will process one more time. So if we wait for 30 seconds, you should be seeing a few more processing of this error records again. So here in this Lambda logs, you can see this is processing 5, which has all the exception messages. And similarly, you can see all the other exception messages here, which means it has completed processing it 2 times and it would have sent it to the dead letter queue. So if we come back to the Amazon SQS dead letter queue and look poll for messages, you will see all the messages that will be erroring out because of the word exception in it that we just sent now. So we see all those messages inside this queue. So if we navigate into one of them, this is the first message. So let's go to the other one and it says test exception 15. And you can see all the other messages as well. Now, once you have fixed your code or the external service is back up, you can again redrive these messages into the main queue and get it processed again. Now for the processing of all these messages, we just have one single point, which is our Lambda function. And you can continuously process these messages into this queue based on the dead letter queue and the original queue. I hope this helps you to understand how to set up an SQS in between an SNS and a Lambda function and process the messages more efficiently. Now one thing to notice is in both scenarios, there can be duplicate messages and your code should be able to handle them, which means it has to be idempotent. You also need to make sure that you're not depending on the order of messages for processing these because it can be out of order. Especially when you're retrying a message, it might not be in the same order as you are receiving them. We saw with SQS and Lambda function, we can batch the records and process multiple of these messages at the same time. This also reduces your cost of running Lambda functions as opposed to running one Lambda function per message in the case where we saw with SNS. Even with SNS, you can control the number of records, but you cannot batch these records together. Now you'll have to pick and choose based on your application needs and the scenario that you're processing these messages for. Now, if there are scenarios where the messages can error out or exception can happen, it's highly recommended to use the SQS in the middle. If you like this video, please make sure to hit the like button. If you have any questions, feedback, or comments, do drop them in the comment section below. If you want to be notified of future such videos, make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.